What if I told you that the key to a wealthier, more sustainable future isn't in some high-tech lab, but actually in our trash cans? Today, we're going to explore this incredible concept of turning the world's waste into a source of real wealth and energy. So let's start with a really big question. Just think for a second about all the organic stuff we throw away every single day. I mean, from huge farm fields to the little scraps in our own kitchens. What if all of that wasn't a problem we had to manage, but instead a resource just waiting for us to unlock it? To help us unpack all this, we're digging into a fascinating collection of research called Biomass Wastes for Sustainable Industrial Applications. It introduces this really powerful idea they call the waste-to-wealth approach. And we are not talking small scale here. This is huge. The amount of biomass waste is going up and fast all around the globe. Now that creates a pretty serious disposal challenge. But as our source material argues, where there's a challenge, well, there's also a massive opportunity. Okay, so to really grasp this opportunity, we first have to get crystal clear on what we're even talking about. What is this stuff? At its core, it's actually beautifully simple. Biomass waste is just any organic material that was once living. It's the leftover stalks from a cornfield, it's the sawdust from a lumber mill, it's even the coffee grounds from your morning brew. I mean, it is literally everywhere. The source material breaks this down for us into three main buckets where all this waste comes from: rural, urban, and industrial. Let's take a quick look. And this visual really drives home the sheer diversity of it all. You can see over in the rural section, you've got agricultural and forestry waste. Then in our cities, it's things like sewage sludge and solid waste. And in industry, it's all the byproducts from things like food processing. So yeah, this isn't just one thing, it's this vast, interconnected stream of resources. All right, let's get even more specific. In rural areas, yeah, we're talking about things like crop stalks and wood chips. In our cities, it's the food scraps and paper. And from industry, you get stuff like sawdust or bagasse. That's the fibrous gunk left over from sugarcane. The big takeaway here is that the raw material, or feedstock as the experts call it, is just incredibly varied. Okay, so we know what this stuff is and where it comes from. That's part one. But part two, well, that's where the real magic happens. How do we actually convert all this material into something valuable? The source text lays out two main conversion pathways. First up, you've got thermoprocess. And you can think of this like a high-tech pressure cooker. You use heat, but without oxygen, to break down the biomass into things like biofuels and combustible gases. Then you have the bioprocess path, which uses microorganisms, bacteria and yeast, to literally digest the waste, producing things like biogas and other valuable chemicals. This flowchart right here gives us a fantastic map of the entire journey, using rice straw as our example. See, you start at the bottom with the raw stuff, the feedstock. Then it moves up into pretreatment. That's just getting it ready for processing. From there, you see the fork into those two paths we just talked about: thermal process methods on the left and bioprocess on the right. And you can see how each of these paths leads to a whole different set of products: gases, liquids, even char, which are then used to generate energy at the very top. So to put it another way, that whole complex chart really just boils down to four key steps. First, you collect the raw material. Second, you pre-treat it to get it ready. Third, you process it using heat or those little microbes. And fourth, you generate your final products, from heat and power all the way to things like biofuels and even hydrogen. So, we know what it is and how to process it. Now for the most exciting part. What can we actually create? What does this waste-to-wealth future look like in practice? And listen, this isn't just a theory. This diagram shows a real power plant in a village. It takes rice husks, something that would otherwise be waste, and uses a gasifier to turn them into electricity. That electricity then powers homes and small businesses in the community. It's a perfect example of a closed-loop, sustainable system in action. But it goes so far beyond just electricity. The potential here is absolutely staggering. We're talking about creating biofuels for our cars and materials for batteries. We can produce sustainable hydrogen, which is one of the holy grails of clean energy. We can even create special materials to purify water and build the foundation for bio-based plastics. I mean, the potential is just immense. And just when you think you've got it figured out, the applications get even more surprising. What you're looking at here are microscopic images of biomass bottom ash. Yeah, ash. Researchers found that its super irregular and porous surface makes it an excellent filler material for asphalt, helping create stronger, more durable, and more sustainable roads. From a waste pile to our highways. Incredible. The authors of our source material put it perfectly. They see that in the face of our environmental challenges, biomass waste valuation appears to be a glimmer of light. And that really gets to the heart of it, doesn't it? This is a hopeful, practical solution. So we'll leave you with this thought to chew on. As our global society searches for the next big thing in sustainable tech and circular economies, could it be that one of the most powerful keys has been hiding in the most obvious place of all, in the things we simply throw away?